Hi friends, I am sure you played with seesaw. In this video, we are going to explore turning effect of force. I am going to make this topic really super easy for you, and after you watch this video, try to solving the quiz and top 3 questions on this topic. Link are given below. Let's start from definition of moment. Moment is the product of force and perpendicular distance from the line of action of the force to the pivot. So when any force is applied on an object and it produces a rotation tendency, then that force is known as turning effect of force. So turning effect of force, also known as moment. Moment equals to force into perpendicular distance. Perpendicular distance means the direction of the line of action of the force and perpendicular distance are 90 degrees. So perpendicular distance from the line of action of the force to the pivot, here D is the line of action, perpendicular distance. So moment equal to force F into perpendicular distance D. Unit is Newton meter. Why Newton meter? Because unit of force is Newton and unit of distance is meter. That's why unit of moment is Newton meter. It is a vector quantity. Why vector quantity? We know the physical quantity which have both magnitude and direction is known as vector quantity. Moment, the turning effect of force or moment has both magnitude and direction. That's why it is a vector quantity. There are 2 types of moment, a clockwise moment and anti-clockwise moment. When a force is applied on an object and it produces a clockwise rotation about a pivot or rotation axis or a point, then the product of that force and perpendicular distance is known as clockwise moment. On the other hand, if a force is applied on an object and it produces an anti-clockwise rotation about a pivot or a point or rotation axis, then the product of that force and perpendicular distance is known as anti-clockwise moment. Principle of moment. In equilibrium or in balanced, total clockwise moment is equal to the total anti-clockwise moment. Here F1 produces a clockwise moment and about the pivot, and F2 produces a anti-clockwise moment about the pivot. So total clockwise moment equal to force F1 into perpendicular distance D1 equal to total anti-clockwise moment force F2 and perpendicular distance from the pivot D2. So F1 into D1 equals to F2 into D2. Now conditions of the equilibrium. If an object is in equilibrium or in balance, then total upward force is equal to the total downwards force. On the other hand, second condition, total clockwise moment is equal to the total anti-clockwise moment. Clockwise moment. So conditions of the equilibrium: total upward force is equal to the total downward force. Total clockwise moment is equal to the total anti-clockwise moment. Okay, now center of mass and center of gravity. So the imaginary point of an object where total mass of the object considered to act is called center of mass. So center of mass is an imaginary point where total mass of the object considered to act. It is called center of mass. On the other hand, center of gravity, the imaginary point of an object where total weight of the object considered to act is called center of gravity. Theoretically, both are is the same point. Is the same point, center of mass and center of gravity. So center of mass is related with mass. On the other hand, center of gravity is related with weight. Remember, the imaginary point of an object where total mass of the object considered to act is called center of mass, and the imaginary point of an object where total weight of the object considered to act is called center of gravity. There are some regular shaped object, say it is a triangular shape. This is the position of the center of mass or center of gravity. It is denoted by G. And for a spherical object, center is the center of gravity. For a uniform rod, the midpoint is the center of gravity. For a rectangular object, the intersecting point of the two diagonals are the center of gravity. So the position here, position of the center of mass and gravity for some regular shape object, from some regular shaped object. Clear? Regular shaped object. Hello my dear student, let's start a Igcse O level exam oriented question. It is Edexcel question. The diagram shows how a mechanic applies a force on a spanner to undo a bolt. State the equation linking moment, force and perpendicular distance from the pivot. Here we know moment equal to force into perpendicular distance from the pivot. So remember, moment equal to force into perpendicular distance from the line of action of the force to the pivot. Calculate the force required to produce the moment. Here moment equal to force into perpendicular distance. We have to find out the force. here moment equals to 4.8 Newton meter, and we have to find out the force. But problem is, what is the perpendicular distance? Look at the diagram. Force acts vertically upward. So perpendicular distance means the line of action of the to the is 90-degree angle. That means 40 centimeter. Here it is, perpendicular distance is 40 centimeter. 40 centimeter. But we have to find out, convert this centimeter into meter. So 4.8 Newton meter equal to force into 40 divided by 100. So meter. Now we have to find out the force. So force equal to 4.8 Newton meter divided by 0.4 meter. So calculate this one. Here 4.8 divided by 0.4 equal to 12 Newton. So force equal to 12 Newton. Now the mechanic is not able to undo the bolt because a moment of 9.6 Newton meter is needed. Explain how the mechanic could produce a moment of 9.6 Newton meter. So mechanic is not able to undo the bolt because a moment of 9.6 Newton meter is needed. So explain how the mechanic could produce a moment. So moment depends on two things. Number one, force, amount of force, and perpendicular distance from the pivot to line of action of the force. So we can see the mark scheme. So use a longer. So mechanic can produce greater moment by using a longer spanner. Apply a force a greater distance from the pivot, or apply a larger force, because we know moment equal to force into perpendicular distance. Remember, perpendicular distance from the pivot. So if the mechanic uses a longer spanner, then he or she can produce a greater moment or apply a force greater distance from the pivot, or apply, so distance needs to be greater here, or applying a force at right angle to the spanner. So right angle to the spanner. So applying a force at the right angle to the spanner.